Hello and welcome. My name is Logan Williams. I'm in SIS 140 and this is Windows boot up and shutdown processes. Right here you're seeing just a basic flowchart of the Windows boot up process. Before we begin, I just want to introduce a few things. First of which is the difference between a cold boot and a warm boot. A cold boot is the powering up of the computer from zero power supply, while warm boot is when some software application or operating system causes the computer to perform a reboot. There's also three conditions for a successful boot on the Windows system. The hardware, BIOS, and operating system files function without errors. The Windows boot up process comes in phases: the power on self-test phase, the BIOS ROM phase, the bootloader phase, the operating system configuration phase, and the security and logon phase. The system goes through these phases to perform all required system checks and load all necessary files so the computer can function regularly. The initial phase happens as soon as you turn on the computer, and that is the power on self-test phase. A self-test is performed by the power supply to ensure all current levels are all good before a signal is sent to the computer processor. After the first stage is clear, the microprocessor will then trigger the next phase. The next step is the BIOS ROM phase. After the first phase, the microprocessor will trigger the BIOS to perform a series of operations. BIOS simply stands for Basic Input and Output System, which is a set of instructions that is on a ROM chip contained in the motherboard. During this phase, the BIOS carries out the POST, which performs various hardware checks. It also detects the presence of peripheral devices and the amount of memory present. The BIOS also accesses the information stored in a CMOS chip, which is a complementary metal oxide semiconductor chip, which is on-board battery-powered semiconductor chip inside the computer that store information used in startup processes. The BIOS also accesses the information stored in the DIP switches, which are an arrangement of switches in a dual-line package, hence DIP, used to select the operating mode of a device, in this case the computer, and jumpers. Jumpers are a short length of conductors used to close, open, or bypass part of an electronic system. They are used to configure printed circuit boards like the motherboard of a computer. After all the information is accessed, the system will carry on with SMART, which is the system's own diagnostic test. SMART stands for self-monitoring, analysis, and reporting technology is used by the computer to detect and report on various indicators of reliability. The system will determine the sequence of devices to load depending on the settings of the BIOS to start the operating system. This will continue until the master boot record records and copies all execution, no errors are found in the process. As we move from the BIOS ROM phase, we go into the bootloader phase. After the successful execution of the master boot record, the control goes to the partition loader code, which accesses the partition table to identify three things: the primary partition, the extended partitions, and active partition, all of which is needed to determine the file system and locate the operating loader file, NTLDR. NTLDR is commonly referred as the NT loader and is the file that begins the initial Windows booting process. Without it, everything will fall apart, metaphorically, and the system can't boot. The NTLDR will switch the processor from real mode to 32-bit protected mode when memory paging is enabled. The NTLDR will call upon the boot.ini file located in the root directory to determine the location and entries of the operating system boot partition. As this is happening, the boot up menu will display for the user for the selection of an operating system if you have more than 2 operating systems installed on the computer. NTLDR will pass all information from the Windows registry and boot.ini file into ntosKernel.exe. The next phase is the operating system configuration phase. NTSOKernel.exe will begin to load the XP kernel, hardware abstraction layer, and registry information. The control is then passed over to the DOS-based ntdetect.com program, which collects and configures all installed hardware devices. Symantec.com then searches for hardware profiles information and then loads the software drivers to control the hardware devices. The final phase in the boot up process is the security and logon phase. NTSO kernel.exe will start up winlogon.exe, which triggers all the lsass.exe local security administration, which is a logon dialog interface everyone is familiar with. The interface prompts the user to choose a profile and verifies necessary credentials before being transferred to the Windows desktop. This completes the boot up process. Now we move on to the Windows shutdown process. Initiating shutdown process. The shutdown process begins with a program called the Windows Exit Window X function. This function is responsible for sending an RPC, which stands for Remote Procedure Call, message to CSRSS to tell it to begin the shutdown of the system. The CSRSS receives this message and it sends another message to WinLogon. WinLogon then calls Exit Windows X for a second time, who sends another message to CSRSS, which says that shutdown is authorized. The CSRSS performs the duty of shutting down all processes running currently on the system. The CSRSS loops through all of the processes in reverse of their specified shutdown level. The specified shutdown level is a special number that programs can set to specify the order in which they should be shut down in regard to other processes. If a particular process is a console application, for example, a command prompt, it does not have a top-level window with which to receive window messages. Console applications register control applications during shutdown. It sends the CTRL logoff event to it. This will return either true, which prevents the shutdown, or false, which continues the shutdown. When false is returned, CSRSS will then terminate the process. After all of the processes in the user interface have been terminated, the WININIT component calls Exit Windows X a third time. This time the execution is inside the context of the system process and sends an RPC message to CSRSS living in session 0 on the system. Session 0 is where the services on the system are started and ran from. CSRSS sends a combination of WN underscore QUERY end session and WMN session messages to GUI apps running in session 0. The CSRSS sends the control shutdown event. When the Service Control Manager, SCM, running inside services.exe, an application that responds to the control shutdown event, the shutdown process has begun. When the SCM receives this event, it sends a stop control to all the services that are running on the system. CSRSS has completed its duties in terminating all user session processes and finished notifying system processes running in session 0 that the shutdown is occurring. Control now returns with WinLogon that completes its process by calling the native Windows NT routine NT shutdown system. The system finally starts to shut down. The PO set system power state begins to shut down all hardware. The Input-Output Manager sends shutdown IRPs to all registered device drivers. The Memory Manager now writes any modified memory pages with file data back to the respective files on the storage system. The Configuration Manager flushes any registry changes back to the respective Hive files. The Input-Output Manager notifies all the file system drivers about the shutdown. And finally, the Power Manager completes the entire shutdown processes by powering off the system. The shutdown process is now complete.